As you saw in the other video, as water heats up, it goes through various phase changes. Down here at A, we have solid ice, and in a solid state, water has all friendship bonds made. Every hydrogen bond it can make, it has been made. And when it makes every hydrogen bond that it can possibly make, it ends up making this nice lattice, and it increases in the space it takes up, and that's why ice is less dense than liquid water. In the first phase of going from any temperature below 0 up to 0, the ice is heating up. The molecules are vibrating faster, but the hydrogen bonds remain intact because it still remains as ice. As soon as you get to 0 degrees Celsius, all of the energy that's being put into the ice is being used to break the bonds. If the energy is being used to break the bonds, that means that the temperature will stay at 0 until hydrogen bond is broken, and then it will start working on the water molecules again, making them vibrate faster. Molecular movement is what heat is, and that is what's being measured in a thermometer. That's what's being measured in temperature. After every hydrogen bond is broken, because breaking of bonds requires the input of energy, you're heating liquid water up, and this is the calculation that we were doing on the other homework for a calorie. The 4 joules per 1 gram, 1 degree Celsius. This is the amount of energy it takes to heat up water, the specific heat that is specific to water. Once you get to 100 degrees here, all the rest of the hydrogen bonds will be broken. When you go from solid to liquid, some of the hydrogen bonds are broken and the water molecules can start moving past each other, and that's what makes water liquid. When you get up to this phase here, all the energy that goes in is going towards breaking all the rest of the hydrogen bonds that exist in the water phase, that exist in the liquid phase, and it becomes gaseous water, gas, which has no hydrogen bonds. No hydrogen bonds. At this point, the temperature of steam can increase seemingly forever. Steam can get very, 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 very hot, whereas water can only ever get up to 100 degrees Celsius, and then it'll become steam. The rest of the document here, you are to think about this phase diagram for water. So where things are happening. So hydrogen bonds breaking happens in 2 places. We talked about that. Water solid getting warmer. Molecules gaining potential energy. So in this one, you need to think about chemical potential energy versus kinetic energy. Kinetic energy is the movement of the molecules, so the vibration of them, versus potential energy is the bonds. So think about that. Question 3 asks you to calculate the heat of fusion. The heat of fusion is the amount of energy it takes to melt ice without any changes in temperature. That calculation is different than heating up water because the energy is being used to break bonds versus being used to make it vibrate faster. And there's a few more calculations to do, and then at the bottom you're going to look at specific heat of different substances and try and understand what specific heat is. Specific heat is specific to the substance, water, ethanol, aluminum, copper. Every substance has its own specific heat, and that is the amount of joules it takes to heat up 1 gram of that substance, 1 degree Celsius. The properties of intermolecular bonding that go on between molecules really influence various things about the molecules. For instance, their specific heat and their physical properties and their chemical properties can really be influenced by the intermolecular forces. Additionally, there's this concept that I'd like for you to understand. Like dissolves like. That means solutions with the same polarity will mix. Or substances with same polarity will dissolve. Meaning if you put salt into water, they're both polar, salt will dissolve. But if you put salt into oil which is nonpolar, it will not dissolve because there's nothing to break those salt molecules apart. you need something else that is polar to attract the positive and attract the negative and surround it with that substance in order for it to dissolve. So if it's in something nonpolar, there's nothing to break it apart because nonpolar is not attracted to polar things. It's like trying to put a magnet onto wood. It doesn't stick to it because they're not the same polarity. Okay, see what you can do.